You guys had number 1 up until 4. Remember, at triangles, we only had 2 things that we had to remember the whole time. The fact that all the interior angles add up to 180 degrees, and then secondly, the 2 interior angles added up gives me the exterior angle opposite those. Okay, so if you were to look at number 1, I've got 70 theta. Remember theta, that little sign? I don't think we spoke about that yesterday, extra class people. Okay, that little sign we call theta. But that is just another unknown. It's the same as using an X or a Y. Okay, but if I give you theta, then it means you can't say X is equal to. Then you've got to work with theta. Okay, so I've got 70 and theta and 64. Now we know that theta plus 70 plus 64 will be equal to 180 degrees. What will be my reason? Angles of triangle. Right. So now I'm going to move all of those to the other side of my equation. So 180 minus 70 minus 64. So you should get, how much is it? How much? 2046. Am I right? Is that what you guys got? 46 degrees. Good. Okay. Then at number 2. So any questions at 1? Okay. At number 2, you had to make an assumption first. Look at what was given. Remember, in geometry, everything is given for a reason. So they give me angle B is theta. They give me this one is 90. But how big is angle A? They don't give me that. What else do they give me? They give me that this side is 7 centimeters and that side is also 7 centimeters. So do you guys agree that that is the same as this? Okay, so it's a what? Sorry? It's a? The name of this triangle? Isosceles, yes. Remember our little stick man? Have a look. There we go. And at an isosceles triangle, the legs are the same length and the feet are the same size. Okay, do you guys agree? Okay, so I have got to start with saying angle A will then be equal to theta. No, it must be the same as angle B, right? Why was that? Because it was an isosceles triangle, but I can't use that as a reason. What did we say? We say angles opposite equal sides. Do you remember that from Mr. DeToy's class? Yes. We said we can't talk about an isosceles triangle. Let me just quickly draw it here. I'm going to delete just now. There's my little stick man. These two sides are the same and these two angles are the same. And we said that angles opposite equal sides. Okay, so instead of writing isosceles, you must say angles opposite equal sides. You good with that? Right, so now I can actually fill in. Angle A will also be theta. And now I know that all the interior angles added up is supposed to give me 180. So I can say theta plus 90 will give me 180. What's the reason there? There we go. Angles of a triangle. Ooh, okay, so meaning this is actually 2 theta. Because if that was x, it would have been x plus x, which gives me 2 theta. No. Will be equal to 180 minus 90. So 2 theta will be 90. Now I've got to get rid of that 2. So I'm going to divide both sides by 2. So theta would be 45 degrees. Good. Yes. Oh, no, you mean this? That's the little stick man. This theta. It's like X. It's just another type of unknown. But when we work with geometry, we use theta a lot. Yes. Like alpha, beta, theta. Yeah. Okay. You guys all good? Right, can I skip? Quick, quick, quick. I've got too many people talking in between. Put up your hand, ask me. Shh, 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 shh. I just said. Nee, moenie vir my batty. Jy's nou soos my eie kinders. Right, anyone still copying? No one else. Right. Number 3. Okay, number 3, we haven't got all the interior angles. Shh, shh, shh. Ek wil net gou daai tweekies wat so op is dit selfone. Is your phone in front of you? Sit weg of wil jy hom vir my gee vir 'n maand? Bere. Moenie weer rondkyk nie. I saw you as well, yes? So put your phone away or I'll put it away for a month. Right. Number 3. Shh, shh, shh. Number 3, we haven't got all the interior angles. It's weer julle twee. Nuh-uh. So what we can do is add up those two interior angles and it will be equal to this exterior angle. Do you guys agree? Okay, do you guys agree with that? Okay, so we'll start there. We're going to say 73 degrees plus 43 degrees will be equal to X. My reason is exterior. You don't have to write out the full word. Exterior angle, triangle. Okay, so if I were to add those two, X would be 160. Okay, any questions there? Good. Let's go to number 4. Now, number 4, you will see that I have 2 stripes, 2 stripes, 2 stripes. So, did you work out this one first? Wait, stop. You said 73 plus X is equal to 180. Okay, but the 73 and the X is too far away from each other. If you want to say angles on a straight line, meaning you are using this type of thing, meaning that angle plus this angle will give me 180. Can you see that they're right next to each other? So what you could have done is this angle and X, those two, would have given you 180 degrees. Okay, but not the 73 and the X. Yes, they are on one straight line, but they're far away from each other. So it's not like together they give 180. Okay, does everyone understand that part? Okay, so at number 4, what type of triangle do I have? Because it's an equilateral. Good. Now, we know 2 things about an equilateral triangle. The sides are equal and the angles are all the same and they will be equal to 6. Each angle will be 60. So I can skip directly to saying theta will be 60 degrees. Okay, that's it. So this was a nice and easy one. Now, reason is jy mag nie sê equilateral triangle nie. Let me just quickly don't usually ask you guys this. Let me just check for you. Hello? No, we haven't got a reason for an equilateral triangle. No. Okay. Thank you. Ek gaan vir my stop dit. Ek gaan vir jou hier voor in die hoekie sit. Paradise. Right, so I haven't got a reason yet. Right, if you want, you can say equilateral triangle. No, the thing is, I will never ask you, ask it just like that. Like you guys got it at number 4. We would ask you to for instance, I'm going to give you a picture and say, which angles will be equal to each other? That's it. And then you can say angle A will be equal to angle B or equal to angle C. Okay, no reason given there. Okay. Remember, this is now first the basics so far. We're getting to the more. Okay. Right, so number 5 and 6 I didn't let you guys do because it is a difficult one. So let's quickly work through those together. Right, so this is now number 5. Again, they're asking you to calculate the size of theta, but quite a few things were given here. You will see that I've got a big triangle of ABD. That's now this one, the big triangle. Then inside that triangle, I also have a smaller EDC triangle. No. Okay, now if you look at triangle EDC, what do you guys see? It's a isosceles triangle. Good. So what I like doing is that will be the same as this. So even though I don't know how big any one of those angles are, I drew that on my picture so that I am reminded later on that when I get one of those angles, I know it must be the same for angle D, for instance. Okay, now let's start there. Is there maybe any way that I can get either angle D or C2? Yeah, they will both be the same, but can I maybe work out at least one of them? Yeah? Yes, I can use the 160. Have a look. This is on a straight line, right? So do you guys agree that that 60 and angle C2 together will be angles on a straight line? Okay, so that is where we will start. We're going to say angle, have a look, angle C2 plus 160 degrees will be equal to 180. My reason there will be angles on a straight. You don't have to write out the full word straight line. Okay, so let's take it over. So angle C2 will then be 180 minus 160. So angle C2 will be 20 degrees. Okay. Now, whenever I have something like this, I also like writing it on my sketch. So this will be 20, which means that that is also 20. Now, as soon as I got, first things first, we've got to say angle C2 will be equal to angle D, and they're both 20. Why was that? Because it was an isosceles triangle, no? But I can't say isosceles. I'm going to say angles. Opposite equal sides. Right, so then I go fill in my 220s. Now, when you have a look at this big triangle, we have got angle A, we've got angle D, And our third angle is theta. So would I now be able to work out what theta is? What am I going to use? No. It's not an isosceles triangle. Triangle, the big one, the green one now. The big one, I add up my interior angles. Do you see that? Huh? Are you saying no? Have a look. If you look at the big triangle, I can say angle A plus angle D plus angle B. Now, man, look at the big triangle. Will be equal to 180 because that is, oopsie, angles of a triangle. Okay, so let's go say angle A was 90. Angle D we worked out was 20. And angle B was theta. Okay, so let's get theta alone. So move all the other ones over. So minus 90 and minus 20. So theta will then be, 70 degrees. Oh, it's 180 minus, no? Okay, does everyone understand this? Huh? Okay, that will be more like the difficult questions that I'm going to ask. Okay. Sorry? Oh, I don't know. We haven't even set up the exam paper yet. Yeah. It depends on how many chapters we're actually going to ask you guys about, and then we distribute the marks. So it all depends. There's no fixed. Yes. I did post those assessment dates on a group. So your next assessment is actually going to be like a project. It's got a section A and a section B. It's a part that you've got to go and do at home, actually. Section A, you guys do at home. Section B, you've got to study a bit for, but it's very little. And then we have one period in class to finish that. That's you wrote the test. Now then that project, 25 marks. So then your third assessment will be the big test out of 50. And you got that date on your test series page. But just yesterday, we actually decided that we're going to move your date. You were supposed to write the Tuesday math, and the next week Tuesday, that very last week, you were supposed to write English on the Tuesday. So all we're going to do is we're going to swap those two around. So you write English a week earlier and math a week later. Yes. Yes. It's two sections. Section A, which is 11 marks, and section B, which is 14 marks. The 11 marks one you take home. We'll hand that out next week. Okay, right. Let's look at number 6. Shh, 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 shh. Yeah, are you still copying? Okay, quickly finish. Okay, right. Let's quickly look at number 6. All right. So again, we've got to say how much or how many degrees theta is. But again, I've got a big triangle, that one, and inside that triangle, I've got a smaller triangle and another smaller triangle. Okay, so let's look at the one that we just highlighted. What type of triangle is that? Isosceles. Two sides are the same, AD and DB. Okay, what do we know about isosceles triangle? Two sides are the same and two angles are the same, the legs and the feet. Okay, so which angles would be the same? A and B1. A, draai dit heeltyd. A and B1 will be the same. That's why they're numbered B1 and B2. I can't just talk about B because then it's that whole angle. Okay, so we talk about B1. Right. Now, we don't know how big that is. But what I can do is say angle A will be equal to angle B1, and that is because angles opposite equal sides, because it's a isosceles triangle. Okay, so then I can say angle A will be equal to 180 degrees minus that 52 degrees. Nay. And then that answer, I'm going to say divide by 2. Why am I saying divide by 2? 2 equal angles. Good. Do you guys all get that part? Okay, right. So how big, what's 180 minus 52? 126. Okay? Now divide that by 2, which means that I'm going to have 60. Huh? Sorry. 8, so that will become 4. Excuse julle. Okay, so 64 degrees. Right, now as I said earlier, I like writing it in on my sketch. So this will be 64 and that will be 64. Okay. Now, have I got theta yet? No. What can we do next? Yeah, I can do the straight line. She's saying, what about this? B1 and B2 together must give me 180 degrees. No. Okay, so let's do that. So 64 degrees. Oh nee, ek soek 'n dikker pen, excuse. Right? 64 degrees plus angle B2 will give me 180, because that is angles on a straight line. Come again, 1? 128, yeah. Yeah. No, it won't give you theta. I'm actually, don't write this down yet. I think we've got a shorter path to go. Remember, if you want to use theta, the 128 was these two angles together, those two. Right? So if you want to add them and theta, is it because you see them on one straight line? It's the same as what I explained to her just now. When I talk about angles on a line, have a look. There's my straight line. If I take a point on that line, let's say this one. If I draw lines from there, so meaning this and that and that, then these angles all together, they will all together give me 180. I can't say there's a straight line, this angle plus that angle plus this angle will give me 180. Doesn't work like that. These two will give you 180. Those two will give you 180. And this one is 180 on its own. Okay, does it make sense? Okay, I'm going to quickly delete this part because I'm seeing a shorter path. I thought we would first have to go and get angle 2 over here and angle 2 over there. But, yeah. Yes, that little copy, I don't know what it is in English. This, if I just talk about A, you've got to say angle A. Okay, that indicates that it's an angle. Okay, so have a look. If I were to look at this, this big triangle, the big one, do you guys agree that angle A plus theta plus this full angle will give me 180. Okay? The only thing is, I've got the 64, I've got the theta, I just need 2. But I can take 180 minus all of those, and then I'll get what 2 is. No, I'm lying. Nee, het gaan nog steeds nie werk because I've got that one and the theta. No. So we've got to go back. Yeah. We don't know yet because nothing was indicated here. So it's not like that side is the same as this one. Okay. Oh, I left something out here. Dis hoekom dit sukkel. Kijk hoe, there we go. Dis julle twee kom afgeteken dat ek nie dit ingesit het. Okay. So, now that solves everything. Have a look. If you look at this small triangle, can you see BD is equal to BC? Which means that that's also an isosceles. Yes. Okay, good. So if that is theta, it means that D will also be theta. Right, and now I can say, take all the angles. Take angle A plus angle C plus angle D. And that will give me 180 because it's angles of a triangle. Okay, now angle A was 64. Angle C is theta. Angle D was 52 and theta. Does that make sense to everyone? You guys get it? Okay. So, theta plus theta will give me 2 theta, 180. And then let's take the other ones over. Minus 64, minus 52. Right, so 2 theta will then be 110, 116, 20. Just check on your calculators. Is it 64? Am I right? Did you double check? Yes, ma'am. Okay, good. Right, so now I want to get rid of that 2. So I divide both sides by 2. So it means that theta will then be 32 degrees. Okay, are we good? Right, now. Now I want you guys to look at page 149. The properties of all the quadrilaterals. Now, what is a quadrilateral? We know about you've worked with quite a few quadrilaterals. Quad means 4. Okay, so it's a shape that's got 4 sides and 4 angles. Okay? Yes, a square is a quadrilateral. So the quadrilaterals that you guys have worked with so far is a square, a rectangle. You've worked with a rhombus. Have you guys worked with a parallelogram before? Okay, so parallelogram. You know a kite? That's also 4 sides, 4 angles. Okay, so also quadrilateral. And then the only one that might be slightly new to you guys is a trapezium. Okay, right. So, on page 149, there's a summary of all your quadrilaterals. Let's look at the first one. The first one is a parallelogram. Oh, I don't actually like this one. Listen. Page 149. But you guys, what I'm going to do is I'm going to work through this page, but I'm not going to make notes, anything on it. I'm going to give you like a summary page that we gave the grade 8s as well. That's way better than this one. Okay, because this has got too much writing. The only thing that I want to quickly clarify with you guys, let's use the parallelogram as an example. Okay, so A, B, C, D. So if I were to say this, listen, one stripe, one stripe. What does that mean? Those two sides are not parallel. Equal. Okay, so AC is equal to BD. Okay? No, this is parallelogram. Then, if I were to make two stripes here and two stripes there, it means that AB is equal to CD. Now, please be careful because that is not the same as where we've got just one stripe. Okay, so meaning over here, we have got two pairs of sides equal. Two pairs meaning that one and this one, they make a pair. One pair of equal sides. And here I've got another pair. So that's why I'm saying two pairs of equal sides. Do you guys get that? Right, now, when I make a little arrow like that, what does that mean? Parallel. Okay, now what does it mean if two sides are parallel to each other? Yes. So if, look at me, if I've got two sides that are parallel to each other, it means the distance between these two sides or lines are the same. So, have a look. Here I've got parallel sides, which means that the distance there is the same as the distance here. Anyway, between those two lines, the distance will be the same. Okay. If I have a line like this and like that, could they be parallel? No, because the distance here you can clearly see is much shorter or smaller than the distance there. All right. So, what I want to say is you guys must not get confused with the little stripes and the arrows. When it's stripes, it means we are talking about the length of the sides. When it's an arrow like that, it means that they are parallel, meaning the distance between them is the same. Okay? Now, could I say this? Two arrows there and one arrow down here. No. That means that those two are not parallel to each other. Okay. So it would have to look like that. Okay. And then how do we write it? Let's finish this quickly. So then we say AB, and how do we write parallel? Like this. So it's like an equal sign, but vertically. So AB is parallel to CD. And then I make one arrow here, one arrow there, which means that AC is parallel to BD. Okay, are we good? Okay, you guys are not getting homework yet. Okay? But please go have a look at your quadrilaterals.